let's remember our 30, 60, 90 special right triangle. All right, so here's our right triangle. And let's say that this angle here is 30 degrees, or pi over 6. Let's remember the dimensions here of our special right triangle. Let's see, if this is pi 6th, this is pi 3rds. That'd be 60 degrees. Remember what the triangle looked like. It was a 1, 2, 3 right triangle, where the square root 3 was always opposite the pi 3rds, the hypotenuse was 2, and the opposite was 1. So it's just a triangle that we have to memorize. Now, if I wanted to find, for example, the sine of pi 6, well, since I have my triangle, the sine of pi 6 is opposite over hypotenuse, or a half. Cosine of pi 6 is adjacent over hypotenuse, square root of 3 over 2. And the tangent of pi 6 is opposite over adjacent, 1 over root 3. Of course, you can rationalize that denominator and get square root of 3 over 3. Either or is fine. All right, so let's do an example of an angle that's in increments of pi 6. All right, let's find the cosine of 7 pi 6 using A, the unit circle. Okay. B, I'll show you a different method, which I think is a little easier, but we'll use a circle with a radius other than 1. Remember, the unit circle has radius 1. So let's first find the cosine of 7 pi 6 using the unit circle. And let's remember what we need to do. The first thing we need to do is draw our unit circle. We always center it at the origin. Okay, so this is a circle of radius 1. Okay, so let's try to construct that angle 7 pi 6. Well, there's an angle of 6 pi 6, right? That's pi. So 7 pi 6 would be just one more little pi 6 to there. So there's an angle of 7 pi 6. All right. Remember, that little unit is 1 because it's a unit circle, a circle radius 1. And what we have to do, we have to figure out what is the x and y coordinate of this point that corresponds to 7 pi 6. Now, we've done this in the past, but I'll go ahead and do it again. Let's see. First of all, I need to know what the dimensions of this right triangle are. I need to know what the angles are here. Well, I know that's an angle of pi 6. Okay. So I know the general relationship. If I have a pi 6 angle, it's the 1, 2, 3 right triangle. Okay. So remember, if this length is 1, okay, and I want to take this length, which is 2, to convert 2 to 1, I divide each side over here by 2. 2 divided by 2 is 1. 1 divided by 2 is a half. But notice, since I'm in the negative direction, it's going to give me a negative half. That will be the y coordinate. And the x coordinate, well, if this is square root of 3, and I want to convert this length here of square root of 3 over here, I have to divide this by 2. Again, since I'm in the negative direction, I need to put a negative sign there. So here are the coordinates, negative root 3 over 2, comma, negative half. Now, remember, by the definition of the unit circle, cosine of theta was just the x coordinate. Therefore, cosine of 7 pi 6 is just going to be our x coordinate. And we're done. Sine of 7 pi 6 would be negative 1/2. Tangent of 7 pi 6 would be the y coordinate over the x coordinate, etc. All right, so we've done that a little bit before. We found the points on the unit circle, so nothing really different there, but it's a little tricky. Well, let's do it another way, which I think is an easier way. We'll do it with a circle with a radius other than 1. Okay? So this is what we want to do now. Same problem, but let's do it a different way. All right. First of all, please write this down in your notes. Put the tape on pause and write this down. Given a circle of radius r, okay, and the corresponding point on the unit circle, so if I'm given an angle of theta, I get a corresponding point on the circle, and it's not a unit circle anymore because it has a radius other than 1. So I've got a radius of r, got this point. We wanted to find the 6 trigonometric ratios. Well, it's not very hard, okay, because I get this little right triangle here. The sine of theta is going to be the opposite, right, which is the y value over the hypotenuse, r. Cosine of the angle is going to be the adjacent, which is x, over r. And tangent is going to be the opposite over adjacent. Now, of course, cosecant is just going to be the reciprocal. So cosecant of theta will be r over y. Secant will be r over x. And cotangent, x over y. All right. So let's try this problem. Let's find the cosine of 7 pi 6 using a circle of any radius. And you'll see which radius we'll use. So here's a circle. Again, we knew that 7 pi 6 was this angle to here. So there's my angle. Remember, that little angle was a pi 6. The last problem, we converted this to a unit circle, but I don't need to. Since this is pi 6, we're accustomed to the 1, 2, root 3 triangle, where this is 2. The opposite of the pi 6 was 1, but since I'm in the negative direction, it's negative 1. The side opposite the pi thirds was square root of 3, but since I'm in the negative direction, it's negative square root of 3. Okay? So I didn't need to do any conversion with the unit circle. Okay? So the x value is negative root 3, the y value is negative 1, and now if we want to find the cosine of 7 pi 6, it's just adjacent for the x value over the radius 2. Exactly what we found the last time. Okay? But this was a little easier. We didn't have to go through all this conversion. Okay? Now what would be the sine of 7 pi 6? Sine of 7 pi 6 is the opposite, which is negative 1 over hypotenuse, which is 2. All right, let's try one more example. Let's do one that's in degrees. We need to get the habit of doing both radians and degrees. So find the 6 trig ratios corresponding to the angle 690 degrees. So let's just draw a generic circle again, centered at the origin. Let's figure out where that angle 690 degrees is. Let's see, if I went around once, that's 360 degrees. If I went around twice, that would be 720. So I'm going to have to back off. I'm not going to go quite around twice. I'll back off 30 degrees. Okay. So this little angle would be 30 degrees right there. And there's an angle of 690. So we didn't quite go around twice. We went around once, and then we almost went around twice, but we just backed off 30 degrees. And notice I get a triangle here. Okay. If this angle is 30 degrees, that means it's pi 6. Again, I know my special right triangle. If this is pi 6, it's a 1, 2, square root 3. Let's see if all our signs are correct. See, the x is in the positive direction, so that's positive root 3. The y is in the negative direction, so that's negative. Hypotenuse is always positive. Now I can find my trig ratios. I can find anything I want now. Sine of 690 degrees is the opposite over hypotenuse. Cosine of 690 degrees is adjacent over hypotenuse. See, it's fairly easy now that we've found this nice little triangle. Tangent of 690 is opposite over adjacent, etc. Notice cosecant, which is reciprocal, is going to be negative 2 over 1. Secant will be 2 over root 3. Cotangent will be square root 3 over negative 1. And we're done. So I think it's very easy if we use a radius of any length that we want, and just use the radius of the hypotenuse of those special right triangles. Get your points, okay? Make sure that you get the signs correctly, okay? And once you draw your little right triangle, just know your trig ratios. Sine is opposite over hypotenuse, etc. All right? So practice this. I'll give you plenty of homework exercises to try. And again, if you're having a little bit of trouble here, come by the Polia Math Center, and we will straighten you out there.